Hi, in this video we're going to learn about common and natural logarithms. At the end of the video, you are expected to learn how to use the common logarithm property and also the natural logarithm property. We will start with a review of our logarithmic functions. Logarithm is defined as for x is greater than 0 and a is greater than 0 and that a is not equal to 1. Y is equal to logarithm base a of x if and only if x is equal to a raised to y, because a logarithm can be rewritten in its exponential form. The function given by the function logarithm base a of x, read as logarithm base a of x, is called the logarithmic function with base a. Every logarithmic equation can be written in an equivalent exponential form, and every exponential equation can be written in logarithmic form. The equation follows: y is equal to logarithm base a of x is equal to x is equal to a raised to y. Both are equivalent because exponential form can be written in logarithmic form and vice versa. Now, what is common logarithmic function? The logarithmic function with base 10 is called the common logarithmic function. If you don't see any base, like there's no a, it means it's actually 10. Since it's just a 10, not any number, and if there's no base written, it means 10, the same properties applies for the original properties of your logarithms. Logarithm base a of 1 is equal to 0, it means a raised to 0 is equal to 1. Logarithm base a of a is equal to 1 because a raised to 1 is equal to a. The same works for everything if a is 10. Another logarithm base a of x, the power can be written in front of the logarithm, and that if this expression is equal to x, a raised to logarithm of the power logarithm base a of x is equal to x. This is inverse property. Just remember, if you have a raised to the same logarithm of base a of x, a raised to logarithm base a cancels each other, it's equal to x. Just remember, a raised to logarithm base a cancels each other. Whatever is the value on the argument, on the exponent, that's the answer. And that's the inverse properties for logarithm. And then the last one, the one-to-one, logarithm base a of x is equal to logarithm base a of y. We can just cancel the same logarithm and write the equation x is equal to y, which are the arguments equation. Now, to apply the property, solve for x. Logarithm of x is equal to logarithm of 3. Again, if there's no base, it means it's 10. Using one-to-one property, x is equal to 3. It does not matter if there's no base, it means both are 10. We can still apply one-to-one property. Next, there's no 10, base 10, but actually logarithm base 10 of 10 is equal to x. Logarithm of 10, the base is missing, but it's actually 10, which is common logarithm. So how many times 10 is multiplied to get 10? It's 1. So using the property 2, we can conclude that x is equal to 1. Next, again, there's no base, it means base 10. How many times 10 is raised to itself? 1. Then we can conclude that whatever is the value of the power here, so that will be your answer, because logarithm base 10 of 10 raised to x, the expression, the power in according to your power rule, can be written in front of the logarithm. So this is actually 1. Logarithm base 10 of 10 is 1. Whatever is the value of x, that's the value of the expression. So therefore, this expression is equal to x, whatever is the exponent's value. Next, 10 raised to logarithm of 14. Again, there's no base. Logarithm, it should be logarithm base 10 of 14. Since there's no base, it means 10. 10 raised to logarithm of base 10 cancels each other, so therefore the answer is 14, and that is your inverse property. Again, 10 raised to the power of logarithm is actually equal to 1. Whatever is the argument's value, that's the answer. That is the inverse property. And that's your common logarithmic function. It follows the same original property, except that if there is no base, it means it's 10. It's like a square root. If there's no number, it means it's 2. Okay, let's proceed. What about natural logarithmic function? The function f of x is equal to e raised to x is 1 to 1, so as has an inverse function. The inverse function is called natural logarithm and is denoted by the special symbol ln x, read as the natural logarithm of x or ln of x. For natural logarithm, mathematically, for x is greater than 0, y is equal to ln, where we're going to use this one instead of the natural logarithm of x, ln x of x, ln of x, y is equal to ln of x only if x is equal to e raised to y. The function given by the f of x is equal to logarithm base e of x is equal to ln of x. If your base is e, then it is the natural logarithmic function. Again, if the base is e, it's called ln. Log base e is ln. But it says here, the equation y is equal to ln x and x is equal to e raised to y are equivalent. Note that the natural logarithm ln x is written without a base, because ln is actually logarithm of base e. The base is understood to be e. But what is e? The number e is a famous irrational number and is one of the most famous important numbers in mathematics. The first few digits are 2.71 and so on. It is often called the Euler's number, after Leonhard Euler. E is the base of the natural logarithm invented by John Napier. The number e is found by using the expression 1 plus 1 all over n raised to n. If this is a huge number, 1 is just added by getting smaller and smaller and smaller number. It can never be greater than 2 point something, but actually this is the approximate value, 2.71, and so on and so forth with this expression. And since it's not exact, it is represented by e. Now, the following properties of logarithms are valid for natural logarithms. It's actually the same, except that there's a different representation. Remember, if it's ln, it's actually logarithm base e of 1. Logarithm base e of 1 or ln1 is equal to 0 because if the base e raised to 0, then the whole expression is equal to 1. ln base e of e or logarithm base e of e, it's now ln e is equal to 1 because e raised to 1 is equal to e. Ln e raised to x is equal to x because we can write x in front of ln, which is the value of x. And if e raised to ln x, which is actually logarithm base e raised to logarithm base e cancels each other, so the answer is x. This is a representation of your inverse properties. And the last is 1 to 1, ln of x is equal to ln of y. Then we can just cancel ln, which is actually the natural logarithm, but it actually represents logarithm base of e. We just cancel ln, and ln x is equal to y. This is your 1 to 1 property. How do you apply the property? Let's have examples. Use the properties of natural logarithms to rewrite each expression. Let's have letter A, ln 1 over e. Answer: since e can be rewritten into exponent of -1. -1 can be moved and written in front of the logarithm. Ln is actually logarithm base e. Logarithm base e of e is actually equal to 1. The final answer is -1. We apply the inverse property. Next, how do you evaluate e raised to ln raised to 5? Remember, e raised to ln is actually logarithm base e. It cancels itself. It cancels each other. Therefore, since e cancels ln, the answer is 5 by inverse property again. Next, if you have 4 times ln of 1, 4 is actually a power. And so ln here, what actually happened here is that logarithm base e of 1 is actually how many times logarithm of base e multiplied to itself to become 1. Therefore, the exponent is 0. So this whole thing is 0. 0 times 4 is 0. So the answer is 0. The whole expression becomes 0. That's by property 1. Okay. Next, how about 2 times ln e? Remember, logarithm base e of e is actually equal to 1. So you would expect the answer is 2 because ln, like this, I have not shown it here. The ln is actually logarithm base e of e. The whole thing becomes 1. That's why it's 1 here. Times 2 is equal to 2. Just remember, ln is actually logarithm base of e. You should have learned that the property of common logarithm, if there is no base, it means base is 10. If it says ln, it's actually logarithm base e. You also try to review your properties because they can get confusing. You just go back to the list of properties and it should help you solve problems. Thank you.